So, welcome everyone to the March Novice Meeting. My name's Chris Morissette. I'm the Novice Chair for the Houston Astronomical Society. And I think we got a really cool presentation tonight by Mr. Dan Roy. He's going to give us an Astro-Potpourri. And so what I'm going to do here is kind of summarize what Dan will be talking about tonight. So bear with me. I'm reading a little bit off my phone. But his talk will be about sharing interest and fun tricks you can use in the field, as well as to intrigue or amuse your guests at a party. So this presentation will include basic optics you can try with a magnifying glass. Um, you can learn how a refractor magnifies the image of an object. You could show the moon. He will be showing us an Earth moon model in the moon phases wearing a headlamp. Um, Using Stellarium to guide stargazing. And also, probably most importantly, talk about outreach and how that's important. It's fun, and it is a great way to give back to the astronomy community as well as practice some of the skills that you picked up in some of the other things that you picked up in the club. So, a little bit about Dan. He is a retired engineer and living in League City who leads free public STEM events such as astronomy in my microscop microscopy, which is looking through a microscope, in the park. He serves on the board of the Foundation for International Space Education. He teaches at United Space School and is the Education Outreach Coordinator for the Houston Astronomical Society. So Dan enjoys science, astronomy, microscopy, the outdoors, and of course, helping the wife Rebecca do take care of all the honeydews on the honeydew list. So anyway, without further ado, I'm going to turn it over to Dan. And one thing I'll ask all our participants to do is, as Dan's presenting, go ahead and, if you would, go on mute and put any questions that you might have in the chat. And then at the end of Dan's presentation, we'll come back and go through the questions. So take it away, Dan.
Yeah, I wanted to give people a chance to adapt to my accent. So I wanted something that the je ne sais quoi, that would allow me to show how I pronounce potpourri, because I have trouble pronouncing the R's. And Chris doesn't have the money to give us subtitles. So this is what you're stuck with. But the potpourri, as you probably know, is a little bowl typically with dried flowers and spices that is supposed to perfume the environment. So I just hope that this toy doesn't stink. Okay. All right, let me go to the next one. He doesn't let me. Oh, I'm telling you, I hate this thing. Okay, so this is a little whiff of optics. Our fisherman here is trying to basically skewer a fish, but if he does aim his spear where he thinks the fish is, he's going to miss. And he's going to miss because of the laws of refraction. And the laws of refractions are relatively simple, actually. They are very well known for at least the 18th century and actually much before that. Basically, you have an incident beam of light here from a medium 1 going to a medium 2. Medium 1 is characterized by this number here called an index of refraction. And when the beam of light penetrates the second area with an index of refraction 2, there is a relationship between the angle of incidence, theta 1, and the angle of refraction, theta 2. Are you still with me? Or did I already lose you guys? Okay, this is given by this law that I was taught in school is the loi de Descartes, but you probably call it the Snell law. In any case, I think this guy here, Mr. Sa'adallah ibn Sal, at the height of the Islamic Golden Age, had discovered this law. So there is also the issue of the Hipparchus of Nicaea, by the way, who about 160 BCE knew that the sun was at the center of the solar system, and he had invented trigonometry. So Mr. Hipparchus is really responsible for a generation of students sweating on that stuff. But I think it has some importance for our race. You see, basically, the Neanderthal had no idea about that stuff. They did not know trigonometry. Whereas we, modern human, sapiens sapiens, knew how to aim our spear to catch the fish thanks to trigonometry, you see. So Mr. Big Bat over there just died of hunger when his mammoth went north because of global warming, whereas Miss Fish Lady here gave us omega-3. So this is the reason why our species, so Homo sapiens, outcompeted Neanderthal. That's really the reason. And I wanted you to know that. Now that I have established that, I want to give you a whiff of retracing because this is how you get those very realistic, very beautiful rendering of quasi-real life objects with, for instance, video games. When a beam of light passes through the center of a lens, nothing happens. It doesn't get molested. But if the beam is parallel to the optical axis and enters the lens, it is refracted, and it intersects the optical axis again at a focal point, in this case, the rear focal point. Now, the beauty of optics, it typically goes both ways. It is bidirectional. What is right to left can be left to right. And rule 3 says that if you have a light ray passing by a focal point, it is refracted and becomes parallel to the optical axis. Finally, if you put those three together, when you have an object here with height, h, you get an object over there which is inverted, and that is a real image. And that is how, basically, a magnifying glass works. Now, unfortunately, I had a wonderful little thing here that will not work. It will not work for you. That's very unfortunate because it's very cute. If you copy this particular URL here, you will be able to play with it, and you will see that it's absolutely fascinating. But when you get this little candle here closer to the lens, you really have what is expected from a magnifying glass. But if you push it all the way back, then all of a sudden it's inverted and all hell's break loose. I mean, it's just, and they can very easily do that. You take a magnifying glass and you get an object close to you, and then you move away from it. And at some point, you will see the object inverted in the magnifying glass. And it's absolutely crazy. But these are the rules of ray tracing. These are the rules of optics. Just, I will try again, but I know it will not work. You do not see anything moving, do you? Do you see anything moving?
Yes, Dan, it's working.
You're kidding me.
No, no,
Oh,
no.
this kills me. This kills me. Okay, this is the magnifying glass. If I move a little bit closer to the focal length, to the focal point, you see that the image becomes bigger, but at some point, poof, it flips the other way. So highly recommended. That teaches you basically the rules of optics. And you can see that if I had known that I could have shown you that, I could have done something that is more similar to what I described before. This is when the beam of light passes through the center, nothing happens. This is when the beam is parallel to the optical axis, it is refracted and passes by the focal. And finally, the three together, when they converge, give you the image that you expected. So I'm just flabbergasted that it did not work in rehearsal, but now it works with you. But I'm happy. I'm happy. For once, it worked. Okay. Now, this is exactly how the eye works, by the way. The lens of the eye is doing exactly what I described, and therefore the image is inverted. And our brain does the flipping. And it's not surprising to me because I think that explains a lot of what the New Yorkers are like. But anyway, another thing I want to mention, in the center of the eye here, the fovea, we have special cells that are full of chromophones that are responsible for basically reacting to a specific wavelength of light, either red, blue, or green. And it is those particular cells at the center of the eye that gives us color vision. The other part of the retina is full of another kind of cell, the rod cells, that are much more sensitive to light, much more sensitive to light. You do not see in color with them, but they are much more sensitive to photons. Even one photon, you can see it with the rod cells. And so I'm telling you this because when you are at the eyepiece, if you really want to see something diffuse like a nebulae or a nebular cluster or a cluster or anything like that, you just don't look at it. Look aside of it because basically you have 20 degrees of fovea in angle, 20 degrees of fovea that are color sensitive, but the rest is not. So at night, you don't care too much about color. If you look slightly aside in the eyepiece, all of a sudden, poof, you will see the lanes of M31. I'm kidding. I never saw the lanes of M31, even in my 12-inch, but that's another story. Okay, so that's another trivia that you want to remember at the eyepiece. And that is also useful on the dark winter night when you want to find the keyhole for your car. Don't look at it or you're going to freeze to death. Look aside of it and poof, it will come into the field as been magic. I mean, that's absolutely magic. Okay. Now I want to give you here a whiff of paleogenetics. Here is a Neanderthal man in love with a sapiens woman. Now, I'm telling you this because we know that we mated with those guys. 50,000 years ago, there was a lot of rolling in the snow, you know? And what is amazing is that we have mitochondrial DNA for this particular species, which is Neanderthal. And we do have about 20% collectively as a species, the entire human race has 20% of the entire genome of a Neanderthalian. However, individually, it's not that much. Individually, we have between 1 and 4% of Neanderthal genes. And that's only for us who left Africa. If you remain in Africa, you're off the hook. You don't have Neanderthal. But the Neanderthalian have definitely paired, mated with us, and we have the traces in the DNA today. However, mitochondrial DNA, which is strictly transmitted along the female line, we do not have a trace of Neanderthalian mitochondrial DNA in any of us. And so that seems to implicate that when a Neanderthal man was mating with one of our women, it would work. But when we tried the same with their woman, nothing happened. I mean, I don't know, and I even never to imagine, but nothing viable came out of this union. And so that's absolutely fascinating. We don't know why. There is definitely an incompatibility, or maybe, not a single one of us could contemplate even trying to make love with this female. She looked like him. But that's another thing that is quite interesting in paleogenetics. There is, by the way, a wonderful group in Germany, in Leipzig, who is doing this work of sequencing very old genome. The record they have at the Max Planck Institute of Evolutionary Anthropology in Leipzig, the oldest they have is 2 million years old. 2 million year old bone they were able to sequence the DNA from. But that's absolutely incredible. And I recently learned in New Scientist that there is a new record, potentially, 7 million years old not by bones, because at that point bones are dust, but they looked at the dirt on the soil of a cave. And by doing some sequencing of species like we do when we do genome sequencing, by doing this highly computer intensive jigsaw puzzle of putting pieces of genes together, they were able to reproduce part of the genome and being able to tell, by the way, that in this cave lived one Neanderthal man and two Neanderthal women. Probably his wife and his mistress. I mean, I don't know. But anyway, that's a very interesting thing that those guys in Leipzig are doing. And I just cannot imagine how is that even possible, the miracle of artificial intelligence and molecular biology. That's one of the reasons why I believe we are living in the molecular biology century. So anyway, I think that this poor woman actually was suffering of presbyopia. Okay. She could not see very well from close. That's why it worked in her case. And I wanted to show you a tidbit, a whiff of what you can do with a very cheap optical instrument, which is a good old reading glasses. I got one of these pair at the dollar store for $1.50 for some reason. And if you just project the image of a 1 diopter reading glass plus one onto a screen, you get yourself a wonderful way to observe the sun. Now, the image is not that big, but this is to tell you that you can have a very simple way to look at, for instance, eclipses that way. In particular, of course, what I did next is cut this particular glass in two, and with one and a lot of very sophisticated engineering, I got myself a sun projector here, and with my very expensive optical bench here, I was able to see the eclipse, albeit not in a very high definition. Don't expect to see sunspots with an image like that. Even though with a magnifying glass, you could guess some, but that would not be the best way to show the eclipse. And naturally, that combination of optics leads me to a telescope, in particular a refractor. A refractor is characterized by an objective here that is much larger in size than your eye, and it has an eyepiece. And so the beauty of it is, because of the large diameter of the objective, you collect more light. But because of the magnifying power of the eyepiece, you magnify angles. So you both have a brighter and a larger image. And that cool or what? This is the optics of a Keplerian telescope. Of course, Galileo did not use that one. Galileo telescope used a divergent lens here because it was easier to make at that point. Okay. And the telescope, by the way, was invented in 1607 by a bunch of Dutch opticians, actually. And in the same city, colleagues of them, other opticians in the same Dutch city, invented the microscope. I mean, I find that absolutely incredible. I mean, I love the Dutch. It's a wonderful people with so much smart. But anyway, this is the Keplerian telescope, circa 1611. So if you look at this particular object here, which is a virtual image of height h, you can see that the angle the angle alpha here of this beam with the optical axis is given, its tangent at least, is h divided by f0. And f0, fo really, fo is the focal length of the objective. And then you have the angle beta here, which is, of course, the tangent of which is f divided by the focal length of the eyepiece. Now you put these two together, and what you get is tangent alpha and tangent beta, which may be confused with the angle itself in radian, because the angles are typically very small. I mean, typically the object is at infinity. So you're talking about a ratio that is basically a ratio of angle, and that is the magnification power of your instrument. So it is interesting to see that the magnification power of the instrument is just the ratio of the focal point of the objective divided by the focal point of the eyepiece. That's so simple. So if you have an objective, an optical tube that is, say, 100 millimeter with some 700 millimeter focal length, and you have a 10 millimeter eyepiece, power 70, which is plenty for the moon, by the way. Another way to look at it, and this is a little bit different. I want this time to look at what is called the exit pupil. I'm interested in the diameter of a cone, of the base of a cone of light, okay, that comes out of the instrument. And for that, the reason for that is that we have a little pupil here that dilates all the way to 7 millimeter for you youngsters. At my age, it's closer to 4. This is the maximum diameter of my pupil when it's totally dark outside. Now, unfortunately, I asked my eye doctor to measure mine. He scratched his head for a while and said, why does that nerd wants to know this? But he told me, and I was absolutely appalled. I said, are you sure, doc? 3.4 millimeter. I mean, I was absolutely flabbergasted. It's so much smaller than what I thought. But that's what you get when you're 77, okay? Sorry, that's the truth. Now, if you look at what's going on optically here, let's look at this triangle here, which is close to the eyepiece focal plane. And let's look at this one, which is close to the focal plane of the objective. Now, those two triangles are clearly symmetrical. You can use the theorem of Thales, which means that if you divide the base of this triangle by its height, and you divide the base of this triangle by this height, you get the same number. Okay, theorem of Thales. They are symmetrical. So when that happens, you can put that into equations, and the ratio of the diameter of the exit pupil divided by the focal length of the eyepiece is equal to the diameter of the objective divided by the focal point of the objective, which means the diameter of the exit pupil is given by the diameter of your objective divided by the magnifying power. Welcome to the good old binoculars, the unsung hero of astronomy. When you have a 750 binocular, it means a 50 millimeter diameter objective and power 7, which means that the exit pupil at the other end here is 7 millimeter. 50 divided by 7, roughly 7 millimeter. Now, if you're a youngster, it's perfect, because the diameter of the exit pupil is the same as your pupil, fully dilated. Now, in my case, the 1050 would be better, more appropriate. Okay. So anyway, that's the way those two numbers in binoculars are related. Let's go back to our couple here. And I want to share with you a whiff of paleoastronomy this time, because they seem to be very happy together. And the reason, again, is that she did not wear any eyeglasses. And all of a sudden, before they can roll in the snow, somebody switched off the light. That is an eclipse. And that must have been very scary at that point. But you can see that it just thinks, I'm off, yet me go kill mammoth when sleeps. And she's thinking, my God, where are the kids? And what happens and why? She's already asking herself questions. And that brings me to a whiff of glory, a whiff of NASA here. We were invited by Space Center Houston to show the eclipses to the public. We had two of them, one on the 14th of October 2023, which was a partial, and the total on 8 April 2024, which unfortunately was totally obscured by clouds in Lake City. But anyway, we were invited to do that, and we had a booth that they installed for us, and they gave us a very nice sign, as you can see, and the place was just a total zoo. We had 2,000 people there, And some woman told me at the end that she had been waiting for half an hour in line for her daughter to be able to see the eclipse through our telescopes. Here is my good friend Hadi Endao here. She is now an astrophysics student at the University of Texas at Dallas, and a very wonderful woman from Senegal. We could argue in two languages. We keep in touch, and she will do very well in life, I'm pretty sure. As for me, I showed up with a very impressive and very sophisticated instrument that cost me an arm and a leg. Basically, I recover an old spotting scope and I put it on a tripod. And by projection technique, I was able to have a wonderful image of the sun. I was flabbergasted by the quality of it. First, I was afraid that this scope would explode on me. I mean, remember, that's what you do when you're a Boy Scout and you want to make a fire. You know, so I was thinking, this is crazy. It's gonna be smoked. But no, nothing happened. I could not even feel any kind of warmth when I would put my finger around there. So it worked beautifully, and I could see the sunspots. Unfortunately, the image doesn't do justice to it. But the beauty of that is that people did not have to queue. I could just show them from a projection. And the only trouble I had with the kids is that they would always crawl on all four and try to put their eye on the eyepiece, which would blind them for life. So I was definitely on the edge for the 3 hours I was there showing the eclipse, and I don't care to do that again. That was very stressful. Okay, so a whiff of the eclipse now. A whiff of the eclipse, as you know, the eclipse is when the stars align right, and we have perfect lines of sight between the sun, the earth, and the moon. And that requires that the moon, which is in an orbital plane inclined by 5 degrees, 4.5 degrees from the ecliptic, is just at the right spot. So that's why we don't have an eclipse every month. And if the moon is very close to the Earth, you have a total eclipse. If it is relatively further, then you have an annular. In other words, the disk of the moon is inside the disk of the sun, which is, by the way, dangerous for your eye. Okay. Now, the difference between the position of the moon at perigee and apogee is 42,000 kilometers. So that's quite a big difference. And if you have a moon at apogee, then you will not get a total eclipse. You will get an annular at best, and typically a partial. But if you are at apogee, then yes, you will get a total eclipse. And the reason for that is just amazing. We have an incredible coincidence between the distance between us and the moon and the distance between Earth and the sun. Basically, the distance between us and the sun is 400 times the distance between us and the moon. And also, the width of the diameter of the moon is also 400 times less, 1/400th of the diameter of the sun. And because of this coincidence, you have this amazing phenomena that you can have eclipses. I find that absolutely incredible. So the reason why I was boring you with a 42,000 kilometer difference between apogee and perigee is that you may know that the moon is receding from us at 4 centimeters per year, which means 4 meters per century. And I was thinking, could Neanderthals see an annular? And I was thinking that if you are moving at 4 meters per century, with 500 century, you're talking 2,000 kilometers. Now, 2,000 kilometer distance between what the moon could do now and what it did then is much smaller, but the 42,000 kilometers between the apogee and perigee. Therefore, yes, the Neanderthal could see the annular eclipse. Hooray! One more reason to run in the snow, I guess. So that brings me to a width of angles, okay? If you want to know how much degree here, put your little pinky at arm's length. That's 1 degree of angle. And that means 2 moons. The moon is 30 minutes wide in angle. So 1 degree is 2 moons. 5 degrees, 3 fingers, like a boy salute. 10 degrees, your fist. 15 and 25. So you may use that in practice if you want, for instance, to be absolutely sure to find Polaris when you're in the field, knowing the difference in angle between the Dubné and Merak here, which is 5 degrees. You start by putting 5 degrees with those 3 fingers, and you not only can check the difference between Dubné and Merak, but you put them to the right. And then from this distance, you use 25 degrees to go up. So 5 degrees to the right, 25 degrees up, here is Polaris. Okay, now it's relatively easy to find, but it's good to know that you can measure angles like that, and that gives you a good way to have an approximate measurements of distances between objects. And that is a good way to check on the star charts that you're really looking at the thing you think you are looking at. One of my favorite way to represent the Earth-Moon system is foot. I say foot is width because basically I took an apple and I took a cherry. And the ratio between those two in diameter is about 4. Okay, you can see on the meter here, on the measurement device here, that you have 8 centimeters here, and you have 2 centimeters there, roughly 4. Now, knowing that the distance between the Earth and the Moon is 30 diameter, then you're in business to building any kind of Earth-Moon system you want. You know that if in particular this apple here is 8 centimeter wide, then by 2.40 meters, you have a separation between Earth and Moon. Okay, so that's what I did in this example. I was given a little model from the wonderful people of the Association of the South Pacific, the Astronomical Society of the Pacific, thank you, which puts together this program called NASA Partner Eclipse Ambassador. I went through that with my partner. I showed you before, Hadi Endao, who is now studying astrophysics at UT Dallas, and we got this degree together. And we had, as part of our degree, to produce presentations, and that's what we did in schools and here at Johnson Space Center. I'm sorry, at the Space Center, Houston. And basically, with what they had given me, which is a little ball that was 4 centimeters in diameter, and the moon, which was 1 centimeter in diameter, they had to be separated by 1.2 meters, and that's what I'm doing here, showing the Earth-Moon system as they are, relatively speaking, to scale. Then I demonstrated the phases of the moon with a headlamp. I had a headlamp, and I was illuminating a moon globe, and then I very slowly rotated counterclockwise, always to my left. And if you do that, the audience will see the phases of the moon. Very simple and very appreciated by the kids. They love it. And with all that, we're rewarded by NASA. We are given access to the first projection of the movie Space Race, where we met Captain Victor Glover, the astronaut of Apollo, the next Apollo 2, forgot the name now, the sister of Apollo, senior moment, forgive me, Artemis 2. He will be circling the moon in Artemis 2. Really great guy, they all are, those astronauts, and captain in the army. And every month, on the second Saturday of the month, HIS organizes an outreach for Leak City. I'm friendly with the park services I've been cleaning the parks with them for a long time. Finally, a job I can handle, cleaning the place. But they are very nice to us, and they put together advertisements for our star parties. And the first thing I do is I go to this particular site here, which I strongly recommend, theplanetstoday.com. And that shows me the positions of a planet on the ecliptic that night. So, for instance, tonight, okay, the 5th of March, I'm sorry, this is European way of, of showing the date. On the 5th of March, tonight, then this is where Jupiter, Uranus, Neptune, the Earth, Mercury, and Mars, okay? So I can tell you that forget Saturn. Okay, it's in the glare of the sun, but Jupe will probably be very, very easily seen, and Mercury will be lost in the glare of the sun, unfortunately. But anyway, that gives you a good idea of where the planets are. So what I do is that I put together a model like that, where I put this map on the ground, and I put this ball you see at the top, which is a tennis ball wrapped in tin foil, as the sun in the center. And then I have little planets that are basically wooden tents, articulated wooden tents. And they are connected to the sun by a string, the length of which is proportional to the distance, the average distance of the planet to the sun. So I don't do elliptic, okay? I just assume that all the planets are circular, and that's good enough for my solar system model. And of course, I have to entice the help of the participation of attendees for that. This participant here is not exactly thrilled with the exercise, okay? But that I prefer, because typically kids of that age will love to kick the ball here as if it was a football, and then I lose the sun. So that's quite annoying. But it's a wonderful way to put together the solar system and show the kids the incredible distances involved. Okay? And this is what I've done several times for schools and libraries. I put together those little wooden tents with an articulation in the middle. And also, I drill a hole in each one of them. And the hole is to the scale proportional to the size of the planet. And that really surprises the adults. The kids don't care too much about it, but the adults are absolutely flabbergasted when they see that, because they see those distances and the very small hole in the tent that represents the planet. Here is the biggest I have, Jupiter, you see. It's not even a quarter. I think it's about a penny. So you're talking about very small size and huge distances, and that is a wonderful way to explain the size and challenges of the solar system. Another easier way that I found is to have this particular thing here, which is a poster of the different planets to scale. And again, you can see by the scale here, the meter, is that I have about 2 centimeters for the Earth. And so Jupiter is about 10. So you're talking about something that is very concise. And what I like about it, that I selected a scale such that I can give this to a man or woman in the audience who is 6 feet tall. Because at 6 feet, it exactly represents the size of the sun, the same scale. So there is the sun, 6 feet tall person who is carrying this particular poster, and it gives you the entire scale of size of the solar system. Very easy to do, and very cheap too. I'm very cheap. My wife will tell you that. So it's very. Another one that I like, by the way, I forgot to tell you that if you want to have basically an Earth-Moon system in your library, I've done that many times. You take a basketball and you take a tennis ball and you separate them by 25 feet. That's exactly to scale the size of the Earth, the size of the moon, and the distance between the two. Okay, very cheap too. Okay, I cannot more warmly recommend Stellarium. Stellarium is a magnificent planetarium. The price is right again. I share two with you. This one, which is the one I use that you can put on your cell phone, and this one, which is said to be more user-friendly, but I respectfully disagree. The website, the web version, I did not think particularly friendly. But anyway, this is something that you may want to do because you have really access to it so easily on the net. Okay, and by the way, you can send me email at the end of the show. I can show you all those particular URLs. I prepared a YouTube particular clip on this, and if you go to YouTube and in the search box you say Stellarium Daniel Roy, that's what you're gonna get my tutorial for better, for worse. Okay? And I did the same for Kepler's law. If you want to know what Kepler's laws really are like, you do the same thing. Go to YouTube, you say Daniel Roy Kepler laws, and you will see this. You will not hear, unfortunately, the music. I selected Gustav Holst, the planets, and of course the Jupiter movement in this case. But it allows you to see the dance of the Galilean satellites. And basically, in the clip, I explain how the Kepler's law work, and I make the point that he want to make sure I don't tell you the wrong numbers. Io goes around in 1.75 days. Then Europa, 3.5. Then Ganymede, 7. You see the progression here? 1, 2, 4. Okay? And Callisto breaks the particular trend, but this is to show that Kepler's laws really work. Okay, and it's based, of course, it was explained. And at the time of Kepler, it was experimental, and you can check it out by even putting the date that Kepler was observing, which is 1610, the 1st of January. And I do that in the clip. And then you can see exactly what Galileo saw that particular night. And you can check his book. And in his book, you can see that the position of the satellites mapped exactly what he described. It is absolutely fascinating. We can do that now. And another thing I want you to know, all the moons, wherever they are, all the moons are tidally locked. Okay? That means they always show the same face to their planet. All the moons do that. And of course, our moon is no exception. And that's the case also in the Jupiter system. And even Callisto, which is far enough, okay? Even Callisto has the same problem. Now, another thing I want to tell you is that whenever we try to put together a base in the Jovian system, it's got to be on Callisto because the environment in the inside Jovian system is horrible. It's worse than nuclear war. Okay, you have a very active, very strong magnetic field at Jupe, and Jupe therefore traps all those ions that come from the sun or outer space, and it is in this belt that we also have on Earth, called the radiation belt, that all those things are collected, and you certainly do not want to go spend a weekend on Europa. Because even though it seems very exciting, we may have a subterranean ocean in there with a crust of ice, which is maybe 200 kilometers thick. And under this crust of ice, you have a liquid water ocean with water that is similar to the water of Earth. So you can imagine little dolphins swimming there. We don't know that. But in 2030, you will have 2 spacecraft who will explore this system. Europa Clipper from us, and the Jupiter Icy Moon Explorer, JUICE, from the European Space Agency. And JUICE will come in orbit around Ganymede. And Ganymede, by the way, is the heck of a moon. Ganymede is bigger than Mercury. I mean, talk about moon, a moon bigger than a planet. Well, welcome to Jupiter. Okay, so anyway. Yeah, now I want to give you a whiff of my country of origin here. There is a place in the center that could be compared to Wichita, Kansas, within limits, of course, because Wichita is much bigger. In Le Creusot, which has, I believe, 300,000 people. Let me make sure I don't tell you the wrong number here. Yeah, that's right. About 23,000 inhabitants. Okay, 23,000 people. And it is very close to a very prestigious area of France. If you know anything about wine, you have Puy FISE here. You have Nuit Saint-Georges, my God. Côte de Beaune. You have Mâcon. Um, you have Beaune. I mean, it's just an amazing place, La Bourgogne. And in this particular place lived a little girl. And at the time, she was 11. She was 11, and there was a star party in her school. And she was able to look at Saturn. And that triggered her interest in the sciences. This little girl was so fascinating. In this little place, where not much happened, but she decided she was going to be a scientist. And since she wanted to help people, she became a medical doctor. Now, medical doctor in France do house calls. And this woman here finds herself having to visit customers who are verified from her place. So she got herself a pilot license. And being an overachiever, pretty soon she was multi-engine rated, IFR rated. I mean, she was using her airplane not only to go see her patients, she was using her airplane to transfer organs between hospitals. Now, in 1980, the European Space Agency sent a call for astronauts. They wanted to have people who had all those qualities we expect from those guys, super intellectual athlete as well as athlete, period. And she was a pretty good athlete too, by the way. And this particular little girl was now a woman, was selected out of 10,000 people. 10,000 people applied. They selected 7 men and 1 woman. And that's how Claudie André Techet-Héniré became the first French woman in space. I mean, this is absolutely amazing to me. And then she went to the space station. She did EVA. She was qualified as a space shuttle emergency shuttle. The politicians noticed her. She became the minister of science and technology. But when she could not find the money that she had asked for research, he told those politicians to take a hike. She resigned. And now she is on the board of several high-flying companies all over the world, by the way, not only in France. And she's doing very well. All that because someone let a little girl peer through an eyepiece. And now I want to tip my hat to people I absolutely adore and admire. This is a whiff of dedication here. And this is Amelia and Steve Goldberg. Now, Amelia is just an amazing woman. She has authored the Astronomical League Observing Program, the Universe Sample. She has obtained several major awards, in particular the Astronomical League Masters Observer Award in 2006. She has been inspiring kids of all ages with her pink Dobbs Astrea here and other instruments for over 50 years. And I want you to look at the face of this young woman here during one of the United Space School classes where the astronomy night was at my place. And Steve and Amelia came and my God, look at this woman. This is why we do this. This is why we want to continue doing this until we reach escape velocity, because this is the best thing any human can do, inspiring the next generation. Fantastic people. And as my friend René Gelali said, basically, this couple is the rock star of amateur astronomy. Okay, they got the Omega Century Award in 91, she told me, and the asteroid Stevelia is named after them. How many people can say that? An asteroid is named after them. Definitely very, very deserving. And of course, Steve, I don't want to forget Steve. Steve was president of the club, 1980-1981. That's when the dark side was created. He was also our first webmaster. and he started the first astronomy day here. Okay, he started there, and he, many, according to my friend um, um, René, again, according to my friend René, many Houstonians owe their success in amateur astronomy by the hands-on instruction of Steve and Amelia Goldberg. And by the way, Steve has also dabbled with exceptional plumber because he has fixed the toilet at the website. So, yeah, the guy can do anything. But this is what I love with his group. Okay, people will do absolutely anything that is needed at the time it is needed, and that is the heck of a role model. I will do my best. Now, this is Debbie Moran. She is an in-demand speaker in astronomy. In particular, she has become a literally national level expert in light pollution. She writes right and left about the subject. She is a regular lead science fair judge. She was the very first TSP Astrolin workshop leader, which is geared to the novice observer, by the way. And before Chris took over, she was the chairperson for this group, the group of novices. That's the group she shared. Okay? Another remarkable person. Our Joe Calaf, my dear friend Joe Calaf. Since 7-year-old, he has been observing the sky. And he has given so many talks. He was president from 2019 to 2035. I will try to follow in his footsteps, except being president. I'm sorry. I do not plan to form an exploratory committee. Okay, it is not for me. And I would be horrible in that game, by the way. I got the Omega Century Award in 2017. And again, I believe in 2024, I may be wrong about the year. And I forgot to tell you that Debbie got her Omega Century Award in 2015. We are Omega Century Mafia or something, you know? What else? Oh, yeah, of course, René Gedali. Well, she was president 2015 to 2017. Another one of those remarkable individuals who always does whatever is needed to do. Whenever and whatever. It's remarkable to work with people like that. I love it. When she was president, she revitalized the board by basically making sure she had a good team. She created the first SIG. You know, we take SIG for granted, but at the time, people were snickering at her. You know, SIG women. Or, well, guess what? Now we have 6 plateaux. Okay, we have SIGs everywhere. We have become a potpourri of SIGs. You know, we have all those SIGs right and left. So that's thanks to her. She also started the group meetings, like the barbecue party, the Christmas party. And she will even worked physically to build the bunkhouse at the site. I mean, it's quite remarkable, you know. So anyway, now I want to share the good people who are at the center of HAS outreach program. This is Joyce and Mike Rydorf. This is Bill Pizziri here, who is our best speaker. He has done so many talks at various levels, and here he's seen talking at a school. Michael and Amy Segura, dear friends of me and Rebecca. They help us not only for the STEM in the Park at Lake City, but also they have their own party for the Challenger 7 Memorial Park. Of course, our new president, Matt and Erika, Boerlage, I can never pronounce that, I apologize. Boerlage, Eric and Erika and Matt, and they are taking care of a wonderful show at Clay Park. Of course, Bobby Martin, who is taking care of John Paul Landing Park. And here, my dear friend Clet, Clet, where is it? Yeah, Clet Landry. Clet Landry was with me at Klebs Park and at Cliff Park. Damn, slow down. At Cliff Park. And yeah, I see the clock, so that's why I'm starting to get nervous here. At Cliff Park, which is a special event for kids with cancer, And here we see one of the father of the kids looking through a clear, wonderful 10-inch Dobsonian. Finally, last but not least, my wife, Rebecca, here, who got a Omega Century Award in the 2019. And she is with astronaut Dan Petit, a remarkable astronomer himself, great guy. I strongly recommend his lecture on the rocket equation. It's extremely clear. You can find it on the net. And he is the most experienced astronaut. He has followed anything, and he has so many anecdotes, and great guy. Absolutely. They all are, but these guys are just. So of course, if you are doing outreach, except to get a bigger fridge, okay? And I decided to put all those awards that I consider awards on a special poster. And I find that I absolutely love this particular cute story, cute picture, but I want you to know something else. My son is an avid gamer, okay? He does video games all the time. So he goes through those swivel chairs very fast, okay? And since his father is richer than mine was, he just throws them away. So I decided to reuse those things, and I use the accoudoir in particular, the things you have for the elbow. And that's very convenient. I put my elbow on this thing, and I got the mechanism here of a swivel chair, but I put myself on top of that, a $15 plastic chair from Walmart, and I bolted those accoudoir on it, and that is perfect to watch with binoculars. And again, binoculars are the unsung heroes of astronomy. Finally, I was tired of showing clouds to the kids, okay? So I decided to also show them microscopy, because if the clouds are in the way, at least I can show you, like here, for instance, the ecosystem in a drop of water, which I get in a local lake, or I can show them some prepared slides or some clips that I got on the internet. And that gives me to United Space School, because every year I'm responsible for Astronomy Night. And here you can see Amelia again, the same night I was mentioning before. And those kids, 50 kids from 25 countries, come from for 2 weeks to the area. And this is what they do. I don't think you will hear the music, but have a look at the images. So they spend 2 weeks during which they put together a mission to Mars. That's pretty impressive. And they are absolutely remarkable kids, because they are selected at the national level. Okay, when they come, they are a delegate of their country. So they are very serious, and some of them are not only smart, they are fighting smart. And you should see their bio. I mean, sometimes I get the feeling, this kid is 17 years old. He has done all those things. What have I done with my life? Now, here is one of my kids in particular. This one, Holly, comes from the Isle of Man. And this is the red team. The red team is responsible for everything needed to go from Earth orbit to Mars orbit. And of course, they are with astronaut Sonny Williams here, another absolutely wonderful person. And by the way, when you want to get an astronaut, if you try to go through the channels, forget it. Okay, that will never work. We always get those astronauts by friendly contacts. Anyway, now I want to very quickly share with you, because I'm already out of time, the top people we have seen as part of the program. Here, particular Ms. Mishuka Adiyake, which is Nepalese, but is the United States citizen. She volunteered for orphanage in Nepal. She has become an expert in medical biophysics. She works with astronauts. Particularly, she works with Chris Hadfield and other astronauts in the States. She was on the front line in New York City during COVID. And now she is teaching in Monterey, the next generation. Now, the guy here, Joel Spark, is from Canada. He has a, a company called Spire Incorporated. He has launched 200 satellites that provide data and climate monitoring from various countries. He has over 400 employees across the world, and he is publicly traded on the NYSE. This absolutely beautiful woman here, Sinead O'Sullivan in Ireland, has done Georgia Tech, Harvard Business School, MIT. Okay. She focuses on investment and economics. She was a quant analyst on Wall Street. She is on the technical board, a member of the European Space Policy Institute, and she writes frequently about economics and investment in the Financial Times, institutional investment, and The Economist. And last but not least, my friend Jackson Liebeck here, 2016 from Australia. He came from a very small place. He did not believe he could become an engineer, but United Space School showed him he could. And now he was program director for this particular um, Blue Ghost mission that landed on the moon last March, right side up. Okay, Jason Liebeck is one of my favorite students. Okay, so I want to put a little plug here for this particular program. If you have family nearby, Johnson Space Center or University of Houston at Clear Lake, you can host two of my kids for 2 weeks. Now, you don't have to do much. Just bring them to UHCL in the morning, get them back at night. But very quickly, friendship develop, particularly between the parents. And I can nearly guarantee you, you will be invited by the parents on the other side. And Rebecca and I have so many invitations from so many countries in the world. We'll never be able to honor most of them. And I'm telling you that because I want you to participate in the Astronomy Day of 2026. I'm tired of showing the kids streetlights, and there is nothing more annoying than having class on precisely astronomy night. So I decided to look at the sun and transform it into an observation of the sun in H alpha and white light. So if you're interested in looking at the sun, if you have the instruments that will allow my kids to see the sun, please contact me at my email at the end of the talk. Also, you can check what Steve puts on the website regularly. And finally, I like to share with everybody that comes to the star party something they can relate to and keep as souvenirs. And these are URLs of really good stuff. URLs that is very useful, for instance, free astronomy software. And here's stuff on the net. I don't have time, as I typically do, to go to Astronomical League, but you can have a free book on astronomy, which is wonderful. And finally, I want to put a plug for Retreat, because for 10,000 generations, we've been staring at the night sky and sharing its wonders. So now it's your turn to join us. Join us, outreach and touch someone. It is in your DNA, your mitochondrial DNA. Thank you, mommy. That's all I had. Sorry, I went late.
Nope. No problem, Dan. Hey, thank you so much for all that information. I can attest to the value of outreach. I think I get more out of it than the people that show up. So it's a valuable service, and I highly encourage people to get involved if they haven't in the past. So with that, again, thank you. I don't have any questions in the chat. Does anybody have a question that they'd like to ask Dan before we adjourn? I do have just a couple of
Did
announcements.
anybody understand what I was saying? This is the problem. Sometimes I talk forever and then nobody understood a word.
No, we understood. And Michael, thanks for posting that link to the simulation, the sim bucket. So we've got that. Um, okay, I'm gonna do my auctioneer imitation. I know it is late, so I'm gonna say going once, going twice. Okay, no questions. Again, thank you, Dan. If you could let me share my screen, I'll wrap us up here in short order.
Sorry
So,
about that. Here we
no,
go.
no problem, no problem. So, just a couple of things that I think are pretty good to talk about. Let me get this up. Um, there's a novice lab. We're having our prime night, hopefully weather permitting, on March 14th. So if you want to participate in a novice lab, just come on out on prime night. I'll have a table set up and we can tour the night sky and have fun finding featured objects. It's at the dark site. You don't need to sign up or do anything special. And you'll find out if the event is canceled by Matt. Special interest groups for the month. We had the data SIG last night. Visual SIG, Smart Telescope, and Astrophotography are the next 3 Wednesdays in March. And then, if you would please join us for tomorrow night's meeting, where we have an introduction to the Nancy Grace Roman Space Telescope by a Mr. Dominic or Dr. Dominic Benford. So, with that, I just wanted to make those quick announcements, and I thank you for attending tonight. Dan, thank you very much. We really appreciate it, and I hope everybody has a pleasant evening. Thank you.